In this video, let's talk about a type of center of triangles we call a centroid. A segment joining a vertex to the midpoint of the opposite side is known as a median. There's a nice picture of it up here at the top of the page, and then there's another picture in the box beside where we just wrote those words. So you see that the median joins the vertex to the midpoint of the opposite side of the triangle. The three medians of a triangle intersect at a point we call the centroid. So write medians in that blank. And it says use the diagram to the left to answer the following questions. So let's list the three medians of this triangle. So we have B, vertex B hits point F, which is the midpoint of AC. So BF is one of our medians. I'm actually going to write that in green to match my highlighter. So BF is a median. Another median would be CD, I'll call it that because it goes from vertex C to D, which is the midpoint of side AB. So let's write D, C, or CD. Either way you write it, it's still the same segment of the triangle, which is our median. And then A connected to E. So the vertex A connects to the midpoint of BC, which is the point E, and that's another median. So AE is our other median. The centroid in this triangle is just named with the letter P. That's where they all intersect. And it says what special properties exist for each median. So for each median, we say that the longer segment, so if you look at the first one we named, which was BF, the longer piece of that median, like from B to P, that segment of the median is 2/3 the length of the entire median. So we would say that BP equals 2/3 of the total length of BF. And then that would be true for each of those medians. So we would say that this longer segment of median CD is 2/3 of the total length. So we would say that CP equals 2/3 of the total length of CD. And then let's do that one more time. Let me grab a different color. Let's see, what about blue? So let's say AP, so this longer segment of AE is 2/3 of the total length. So let's say AP equals 2/3 of AE. So it's like a 2/3, 1/3 ratio. All right. So let's look at some examples of how we apply these properties of centroids to a problem. So it says if P is the centroid of triangle JKL and JK equals 22, so let's label. They said that JK equals 22, KN equals 13. So KN is 13 and OL is 18. So let's label OL in purple is 18. And then it said find each missing measure. So they want KM. So we know the medians are touching the midpoint of those sides. So like M is the midpoint of this side in blue. So JM equals MK, and if the total is 22, then each of those segments would be 11. So we could say that KM equals 11. And then what's next? They asked for NL. So we know that if KN is 13, NL would also be 13 since N is the midpoint of that side. So we can fill that in. Then KL would be the total of that side, which would be 13 plus 13, which is just 26. Then JO, so moving around the figure over here to JO. O is the midpoint of that side, and so those two segments would be congruent, and that would make JO also equal to 18. And then JL is the total, so 18 plus 18 would give us 36 for JL. All right, so that's it for example 1. Let's look at another one. Example 2 says if Z is the centroid of triangle TUV and TZ equals 60. So let's label TZ is 60. XZ equals 28. So let's put that in the figure. So XZ equals 28 and WZ equals 25. So WZ is that little one right there, and that is equal to 25. Find each missing measure. So this is the 2/3, 1/3 rule. So ZV is the first thing they ask for, so that's on the green one. So what I like to do is treat it like there are 3 equal parts. So the little one is what we've already labeled as 28. There are 2 more thirds of that line, that segment, that median. So each piece of that would be 28. So there's 3 28s if you think of it as like 3 parts or 3/3. And so ZV would be 28 plus 28, which would be 56. Then let's look at ZY. So ZY is actually the short segment over here. So if we have 60 that we were given, what we can do is break that up into 3 equal parts. So we have 30 and 30, and then the little one is 30. And that helps you answer anything they ask pretty quick. So the next one says ZU, and they gave us WZ, which is the smaller segment. So there's 2 more pieces that would be equal to 25, because these are divided into 2/3 and 1/3. So there's like 3 parts that are equal to 25. So ZU would be the 25 plus 25, which is 50. And then TY, notice we can now figure that out pretty quick, that we've labeled 30, 30, and 30. So we can tell that that would all add up to be 90. And then XV is the green one. So 28 plus 28 plus 28 would be 76. No, not 76. That would be 60 plus 24, 84. Okay, let's look at one more example. So example 3 says if D is the centroid of triangle ABC and DE equals 6. So let's label DE equals 6. And they want to know what BE and BD are. So the same thing would work here. We have the little segment out of that median. There's 2 more parts on the other side of that centroid that would both equal 6. So think about it as 6, and then there's 2 more parts that would also equal 6. And then you can quickly figure out what they're asking you for. So BE would just be all 3 6s added up, which is 18. And then BD my pen is not working, but I'm trying. Let's see. BD would equal 12, because you can just add 6 and 6 together. Let me try to write that a little bit better. All right, BD equals 12. Okay, so that's it for centroid properties and some examples of centroid.